All right, so we wrapped up piecewise functions. That is as far as we're going to go with piecewise functions, but you will see those again next year in Algebra 2. Now what we're going to move into are called rational functions. And basically, a rational function is just involving fractions. And we've done work with fractions, but now you're going to see more like x's involved. And eventually we're going to have polynomials within the fraction. So like what we're eventually going to get into is something like, x squared plus 5x plus 6 over about x plus 2, something like that. And then we're going to work on simplifying that. We're building up to that. We're not doing that yet. Okay, so don't worry about that yet, but that's where we're going. So we're going to just kind of start with just kind of a basic review of how to add and subtract fractions and the fact that we're going to need common denominators. So you might want to write down when you add or subtract, you need a common denominator. So we're going to be adding and subtracting, we're going to be simplifying. And we'll just kind of add on to that a little bit more and more each day. So if we look at this first example up here. All right, I'm adding, so I know I need a common denominator. I'm looking at the denominators, both of them have x's. This one does not have a 4. So if I multiply this fraction by 4, I have to multiply by 4 on top and bottom, because technically that's 4 over 4, which is 1. So I'm essentially multiplying by a 1, and that doesn't inherently change anything. So it's safe to do that. It's legal to do that. Now, because I have common denominators, I'm going to be able to add. Now, I would rewrite this first one. 4 times 2 on top will be 8. My denominator is a 4x. And then I have plus 3 over 4x. Now, when you add fractions together, whatever the common denominator is, that stays your denominator. We do not add the denominators. This is not going to be 4x plus 4x equals 8x. We do not add the denominators. Maybe you write yourself a little note. Do not add or subtract the denominators. The bottom. Whatever is your common denominator stays your denominator, okay? You do add or subtract the numerators, the tops. So I can do 8 plus 3 and I can get 11, okay? And then I need to ask myself, does this simplify any farther? So could I divide 4 into 11? And the answer is no, it doesn't simplify any farther. So that would be my answer. Now, on today's Google form, you're going to have to like write this on the Google form on the computer. So here's how I'm going to want you to write it. I want you to put parentheses around the top stuff. So that would be parentheses around 11. And then you're going to have the little slash. And then you're going to have parentheses around the stuff on the bottom, the denominator, 4x. So that's how you're going to type it in the computer. Okay, parentheses around the top, slash, and then parentheses around the bottom. And I'll keep reminding you of that so that you're ready for that on the Google form. All right, let's do this next one down here. All right, so we are subtracting, so we need a common denominator. Both denominators have an x. This one has a 5, this one does not. So I can multiply by 5, but I have to multiply the top and the bottom by 5 to make it legal. All right, so the first fraction is just staying the same. Now I'm going to have this fraction will now become 10 over 5x. Okay, now I have my common denominators, so I'm to the point where I can actually subtract. The common denominator stays your denominator, so 5x is my denominator. And now I can subtract the numerators. So 30 minus 10, I'll get a 20. Okay, now always ask yourself, can I reduce? And in this case, yes, you can reduce because 20 divided by 5 actually reduces down. Now, 20 divided by 5 is 4, and then you have an x on the bottom of the fraction. Here might be a better way to think of it. If you split this up a little bit, you could do 20 over 5 times 1 over x. Now, careful, this is multiplication is what I'm switching it into because this is 5 times x. And when you're multiplying, you can just like split it. Clean split, clean break. You do not need a common denominator when you're multiplying. So when you simplify, the 20 divided by 5 will simplify to a 4, but then you still have 1 over x. And when you multiply straight across the top and bottom, you'll be left with 4 over x. Okay, now that's kind of the long way behind it. That's the reason why it works the way it works. But here's what I do when I get to, let me clean this up a little bit. When we were here, okay, when we subtracted, we had our common denominator, we did 30 minus 10, and we got 20. So when it comes to reducing, 20 divided by 5 is 4. Okay, there's your 4, but this x is in the denominator, so that's where it stays in the denominator. So that is your reduced version of it. Now, I would want you to always practice how to reduce, but on the off chance that you're just unsure, I guess I would rather you write the not very simplified version down rather than doing some crazy reducing. I want you to try to reduce, okay? Now, when you write this, when you type it in the Google form, remember I'm saying just for correcting purposes so that the Google form can count it as a correct answer, put parentheses around whatever the top is, so a 4, and then slash, and then put parentheses around whatever's in the bottom, an x. Type it in like that, okay? All right, let's try another one. So on this top example here, we're in luck because they have a common denominator already. So I do not have to multiply by anything. I'm good to go. My common denominator is 2x, and all I have to do is add the tops. Now 5 plus 7, we're going to get 12. Okay, so now we always want to ask ourselves, does this reduce? So it does because 2 goes into 12 6 times. This x is down in the bottom. It stays down in the bottom. So that would be your final answer. Okay. Let me give you a hypothetical. Let's say we had the complete flip-flop. Let's say we had a 2x on top and a 12 on the bottom. Okay, well, do you see how the x is on the top? So it stays on the top. Now, 2 over 12 reduces down to 1 over 6. Do you see how the denominator's bigger number stays a bigger number? So this could be written as x over 6. Here, the numerator was bigger. 12 divided by 2 is 6. But the x is in the bottom, stays in the bottom. You might be remembering, oh, hey, didn't we used to move stuff from the bottom up to the top or top down to the bottom? That was when we had negative exponents. We're not dealing with that right now. So don't go back to that kind of thinking. All right, let's try this one right here. So we've got a 15x and we got a 3. We need a common denominator before we can subtract these. So you want to ask yourself, what do they have in common? Well, 3 and 15 have 15 in common. So I can turn this into a 15 if I multiply it by 5. But I also need an x because this one has an x. So 15x can actually be the common denominator. And what I need to do over here is multiply by 5x on top and bottom. Sorry, I'm going to move that star and I'm going to have a little bit more room to write that. So we're multiplying by 5x on top and bottom because 5x times 3 is 15x, and then we will have our common denominator. So whatever that common denominator is, just write it on the bottom. All right, now on the top, we've got 5x times 5. 5 times 5 is 25, and then you have that x. So 5x times 5 is 25x, and then we have minus, and then this is just a 7. There's no x up there. Now this, the numerator, we cannot combine because the 7 does not have an x. So these are not like terms. We can't combine them. So we just have to leave it like that. Okay, now, back to how we type it in the calculator. So remember how I said I want you to put parentheses around the stuff on the top. So I would put parentheses around 25x minus 7. And then I would do the slash for the dividing, and then parentheses around the bottom stuff, around 15x. Okay, and you just leave your answer like that. Type it in like that into the Google form. All right, let's try this one. So again, we need common denominators because we're adding. So you ask yourself, okay, what do 3 and 12 have in common? Well, 3 goes into 12, so 12 is what they have in common. I mean, they have other things in common, like 6, but you want to figure out what you have to do to multiply to get like up to that common denominator. So if I multiply the 3 by a 4, I'll get 12. But I also need to get an x. I need to have an x involved in this fraction over here. So I have to multiply by 4x. Okay, now, did I do that with the last problem? I didn't, but I'm going to write it out. I skipped kind of a step on this one. I just assumed that you remembered that this was 15x here. Maybe I'll write it out. The in-between step that I kind of skipped. So this fraction right here will be 4x times 1 on the top, which is 4x. And then 4x times 3 is 12x. And then I have a plus, and then I'm just going to rewrite this. Okay, now you can see a little clearer that they really do have a common denominator, so we can add them, and that common denominator stays your denominator. And then we add the numerators. Now we have a 4x and we have a plus 5, and those do not combine any more than that because the 5 does not have an x. So these are not like terms. So that's it. That's all we can do. And again, when you type it in the calculator, put parentheses around the top stuff. So put parentheses around the 4x plus 5, and then put a slash, and then parentheses around the 12x. Okay? I just want the Google form to recognize when you are typing in a correct answer. Then let's do this guy down here. Oh, this one's nice. They already have common denominators. Bonus. So they both have a 3. That is the common denominator. So now we just subtract the numerators. So you have 7x minus x. 7 of something minus 1 of something. You're going to have 6 of those things. And then just ask yourself if that simplifies any farther. And this it does, because 6 divided by 3 is 2, and then you have that x. And yeah, technically that's on the top of the fraction, so technically it's over 1, but you could just write it as 2x. Okay? So that is kind of the just introduction where I'm just getting you used to adding and subtracting, getting common denominators, simplifying, that sort of thing. Now, eventually we're going to need to remember how to factor, because that's going to come into play, and that's going to help us when it comes time to simplifying. So factoring, we do need to go back to that, which, every teacher will tell you, keep factoring, keep factoring, keep factoring, because it's a topic that students typically forget, and you're going to need to be able to factor for next year. So this is kind of a nice little refresher, okay? So how do we factor? Well, remember, that's when you set up your two sets of parentheses. And you think about what two things multiply to give you an x squared. So it would have to be x and x. And then you ask yourself, what multiplies to 6? Okay, so you say, okay, what multiplies to 6? Well, 1 times 6 is 6. 2 times 3 is 6. I guess I could have them both be negative, because a negative times a negative would be a positive. So it looks like these are my options of things that multiply to 6. And then what we need to make is we need them to add to 5. So you look at this list of numbers, which of these add to 5? Well, 1 plus 6, that adds to 7. This adds to negative 7. This adds to negative 5. Right here, these two add up to 5. So I'm going to have a positive 2 and I'm going to have a positive 3. And it would be totally acceptable for me to have this entire quantity listed first. So I could have x plus 3 first, and I could have this quantity of x plus 2 written second. Those are equivalent, okay? So it's whatever multiplies to the last number and adds to the middle number. So do you see how this problem had a plus 5x plus 6? And this one has a plus 5x minus 6. So it's going to factor a little bit differently. You have to be a little bit careful, because the x's will still be the same, because x times x makes x squared. But we need to multiply to a negative 6. So when two things multiply together to give you a negative, that means one of them has to be positive and one of them has to be negative. So I could have a positive 1 and a negative 6. I could have a negative 1 and a positive 6. I could have a positive 2 and a negative 3, or a negative 2 and a positive 3. All of these multiply to negative 6. But I'm going to choose the pair that adds to 5, and it's a positive 5. So we want it to add to positive 5. If you add these up, you're going to get a negative 5. So that's not it. If you add these up, negative 1 plus 6, you do get a 5. If you add these up, 2 plus negative 3, you get a negative 1. If you add these up, you get a positive 1. So the only option that adds to 5 is this combination. So I have a negative 1 and I have a positive 6. And again, I can write it, I could put the x plus 6 first and the x minus 1 second. That would also be a good answer. Okay, so I just wanted to do a little review on factoring, because it is going to come up more and more and more. Yeah, so that's it for today. Today you have a Google form. You'll see it on the PowerSchool page. Click there, do that, and then have a really nice weekend. I'll see you next week.